For decades, a law enforcement officer's survival in the field relied almost entirely on a single piece of hardware, the two-way analog radio. But an audio-only channel creates strict limits on what can be shared. If dispatch needs to send a photograph of an active suspect or the precise floor plan of a building, a standard voice frequency cannot transmit that information. This creates a data vacuum in the field. Officers carry significant processing power in the personal smartphones in their pockets, yet they rely on low-bandwidth, audio-only radios strapped to their vests for actual tactical operations. Closing that gap requires hardware that merges the high-speed data capacity of a smartphone with the physical, fail-proof reliability demanded by patrol work. That merger is the modern smart radio. Looking at the schematic, a smart device functions by stacking 4 technological layers into a single rugged chassis. The first layer is secure voice. This ensures push-to-talk remains accessible, but wraps the audio in heavy encryption. The second layer integrates LTE data, giving the radio access to the same high-speed broadband networks used by commercial cell towers. The third layer introduces spatial and optical awareness, embedding the hardware with outward-facing cameras and location sensors. The fourth layer is system integration, the underlying software protocol that syncs the radio's outgoing data directly with the command center. Organizing these features in sequence alters how field personnel interact with dispatch. Instead of merely calling in a report after the fact, they actively stream the environment as it unfolds. Push-to-talk remains the primary tactical function in any critical incident. What changes in a smart radio is the mathematics of the encryption algorithms protecting that transmission. By scrambling the audio signal with complex cryptographic keys, encrypted push-to-talk locks out civilian scanners and prevents interception during sensitive operations. Alongside that secure voice line sits a dedicated emergency button. Pressing it bypasses standard radio traffic, forcing an unblockable, instantaneous distress signal straight through the network. Traditional radio waves are narrow and linear. By embedding an LTE network mesh, the radio expands available bandwidth. That high-speed connection lets officers transfer heavy data files and send instant text messages, communicating detailed intelligence and complete silence. Combining encrypted voice with silent broadband data creates a dual-path communication system. Officers can adapt their transmission method based on the immediate threat level in the room. Alongside active transmissions, the smart radio captures intelligence passively using an integrated sensor suite. Internal GPS modules track exact geographic coordinates in real time. Command knows exactly where their personnel are deployed without ever asking them to call out cross streets over the airwaves. That same LTE connection supports live video streaming. High-speed data turns the radio into a forward-facing tactical camera, allowing remote command to see exactly what the officer sees. Managing those disparate GPS markers and live video feeds requires system interoperability, a framework allowing different hardware units and software programs to communicate with friction. Looking at this network graph, we can see how interoperability functions. The central server pulls those individual GPS coordinates, text messages, and video feeds from the peripheral radios, syncing them into a single dispatch command software. By funneling these distinct data feeds into one centralized dashboard, dispatch operators gain a complete tactical picture, and isolated officers become nodes in a synchronized, multi-sensory network. To see how these 4 pillars function under pressure, consider a sudden, high-speed foot pursuit down a blind alleyway. The moment the suspect runs, the pursuing officer hits their dedicated emergency button. Dispatch is instantly alerted, and the officer's communication channel is prioritized above all local chatter. Sprinting makes it nearly impossible to narrate a changing position. Instead, the integrated GPS passively broadcasts the officer's dynamic location to incoming backup units, saving critical seconds. Simultaneously, the radio utilizes its LTE band to stream a live visual of the suspect straight to the command center while the chase continues. Watching the live feed, dispatch immediately calculates the suspect's trajectory. They use encrypted text and voice to coordinate the incoming units, forming a tight perimeter exactly where the suspect is heading. An automated background sequence of precise location data and secure communication yields a safer, more efficient apprehension than an isolated voice broadcast. Police hardware has shifted from standalone voice transmitters to wearable data hubs. The combination of LTE broadband, unbreakable encryption, real-time GPS, video streaming, and dispatch synchronization now forms the baseline for keeping personnel safe in the field. Secure, high-bandwidth connectivity now defines the modern standard for police communications.